Hi everyone, my class on signal system, right? So I'm just going to start signal system as very important subject like communication. This class we will start signal. It is a fundamental subject, and it is going to be one of the very fundamental network theory, and it will be also useful for controls, and it will be also useful for communication. So this course will be, you can say this course will be for next 20 25 to 30 lecture I will be taking up, and you can score out like 10 marks from this. That's what you have to try. So most of the students are there, they don't understand signal. It is highly mathematical. At the same time, you should have the basic concept. So I have listed down three subjects. These are the three subjects where this subject, signal and system, play an important role. So guys, can you confirm whether my voice is audible or not? Let me check also by myself. Gonna check whether my voice and everything. Wait for the moment. Then we shall start the discuss our plan. Yeah, everything is. So what I'm going to do here is I will be telling you roadmap on signal and system. What are the chapter we have to study? Okay, this course will be for ECE, for electrical engineering, for okay. So this subject is useful for network theory, process communication. And if you don't know signal and system, you can't understand communication. Right? Let me discuss what are the chapter was outlined. Very first chapter will be of signal. Here we will talk about what is signal, what is the meaning, what is the meaning of signal, why signal is so important in our life, right? And we will talk about system, what is the meaning of system, okay? And how signal and system interact to each. You're giving as a signal to the system, so what output you're going to get, right? Those things we will discuss in basics of system, and we will see that how many types of signals are there, okay? From nature, what kind of signal you can obtain, right? And different properties of signal, all those things. And the second chapter will be LTI system. LTI system, it is one of the very popular systems. Is known as linear time invariant system. Okay? So in fact, this chapter is very, very important, where we will talk about one of the very important operation that is known as convolution. In fact, from convolution this year in gate 2 one question was there. Based on simple property, you can solve the question based on convolution. The third chapter will be Fourier series. Fourier series. Fourier series is very important. Okay. In fact, when we talk about partial differential equation, right? There also we use some concept of Fourier series. So Fourier series is also taught in mathematics, but here we will discuss Fourier series in detail. And there will be two kind of Fourier series basically for two kind of signals. One will be continuous Fourier series, one will be discrete Fourier. So here we will talk about continuous time Fourier, and we will talk about discrete Fourier series. This year question was from discrete Fourier series. Okay. So this is my roadmap. You guys can also refer the original GATE syllabus. And we will understand what is the need of Fourier series, why we are talking about Fourier. And the fourth one is going to be the Fourier transform. Fourier transform. Fifth one is going to be, here again we will talk about continuous time Fourier transform and Fourier transforms, continuous time Fourier transform and discrete time Fourier transform. Okay. And after that, after DTFT, after discussion of DTFT, we will also talk about DFT, discrete Fourier transform. Here the T, here DTFT is there and here DFT. So this is important for only and IN, not for electrical. You have to focus. What is signal? What is system? What is LTI system? LTI, linear time variant system plays an important role in all the subject. You can pick up control system. There also we talk about linear time invariant system. And when we talk about any network, also we talk always go for linear element. So this linear word will never leave you. Okay. Uh, but in analog circuit and all, you will also find some of the non-linear diode and all. So next will be here after Fourier transform and all, we will talk about Laplace transform. Laplace. And then we will talk about jet transform. Jet transform. What is the definition, the former definition of Laplace transform? What is the former definition of jet transform? Why we are going for jet transform? Everything will be discussed. But the very first chapter is very, very important, guys. If you understand the very first chapter, rest of the chapter will be very easy for one of you, right? So you have to be very honest and you have to watch the session carefully. Once the session is over, you can rewatch if you don't understand any concept, right? So these are the chapter which I will be discussing. Okay? And some miscellaneous topic also will take. I hope my voice and everything is okay. Uh, in signal, what we are, that's what always property, signal and property. Here we will talk about properties of properties and system. Talk about and what we will that how they interact with how signal and system interact to each other, right? That is what very important. Okay, the interplay between signal and system. Sir, very very important. You are able to understand how they talk. इसी का my voice कट हो रहा क्या बीच बीच में? ठीक है, मैं just I will keep my voice, keep my mic, near my, okay, so that it will not, I think there is some problem, okay, so I will correct that. ठीक है. So in signal and system, we will see how signal and system interact with each other and what kind of output they produce. This is very important to understand. Okay, what we will do here is we will take some here and we will apply some signal. Okay, we will define signal. What is the meaning of signal? Signal is basically a function. You can say some variation. Okay. Uh, as we move ahead, we will define what is signal. Okay. But suppose we are giving some input to the system. Okay, and it will give you some output. So if input is given and the system is given, this is a problem of analysis. This is a problem of analysis. In fact, let me check also my voice is frequently disconnecting or okay. Yeah, it is perfect only. Like we can manage for the moment. Later, I will correct it. Okay. So xt is given to the system and you are getting yt, right? Okay. So uh, if you're giving input to the system, so this system will interact with the signal. Okay, this is kind of an input signal, we call it. Kind of input signal we call it, and this input signal will interact with the system. Systems are many. You can see a network is also regarded as system, right? You might have seen computer system, right? Computer is also kind of system. Okay, that is digital system. So we will apply some kind of an input. Okay, we will classify the signal. Don't worry, just wait and watch. Okay, there will be two kind of signals: continuous time signal. One will be a discrete time signal, right? But let me come to the definition first. Okay, so this is the interplay. Xt will be given to the system, so system will give you some kind of output. Okay, some kind of output. So this is basically the interaction between. What is this? This is basically interaction. Just understand the language. Just understand the language. That's it. Okay? So, because many people, what they do is just they go through the topic, they pick up the question, they solve it. Okay? They don't understand why they are studying signal and system. Okay. So, when signal interact with the system, give you the output. Okay. You might have seen. So, the interaction between signal and system. So this is very, very important. There are various kind of system. Okay, there are various kind of system in electrical engineering. You can say we have electronic system. In fact, in ISC Bangalore, one branch is also there, electronic system engineering, right? So in electrical engineering, there are different kind of system. Power system. Power system is there. You can say electronic system. There is a system like TV is also kind of system, you can say, right? Mobile phones. Okay, mobile phone of the system. Your computer itself is a system, right? Smart grid. Smart grid also a kind of system. So there are various example. If you see the real life examples, there are various examples of system, right? So when you give some input to the system interact with the input signal and it give you the output signal, right? That you have to understand. Okay, so there are various examples as well. Okay, in fact, one of the subject also we go through, that subject is named as communications. There are various examples, you can say, in the real life nowadays. 5G. Okay, we started with 3G, 4G. Okay, now we have got 5G as well, right? We have got 5G. These are what? These are the systems only, right? And there are Wi-Fi, wireless systems, wireless systems. These are the real life examples. Before I get started, what you are waiting for, right? What is signal? The very first question is what is signal, right? And what kind of question will be asked in the gate examination? You guys are waiting for. I know, right? Just wait and watch and see these points. Perfect. So how they interact, okay? And there are different kind of. In fact, nowadays in airport also you will see, right? Radar system, flight system. So when you send some signal, okay, like pilot is interacting, okay, to the ground, okay, just people send some signal, they revert back, okay, these are the signal only, right? In aircraft instrumentation and control, these kind of a system. Okay, so what is the main objective of signal and system? What is the main objective, aim of ss? What is the main aim of ss, right? Properties of both. What we have to see, we have to see basically the interaction between. That is what the main aim. Whether the signal will be continuous time signal, okay, whether the system will be continuous time system. There will be two kind of system. One is continuous time system, one is discrete time system, right? We will see. From the nature, if you pick up any signal, okay, like my voice is what kind of signal? It is an analog signal. Okay, it is a continuous time signal. We'll see the classification. The properties of both continuous and discrete uh, time signal and system, that is our aim to understand. Okay, now the question is, what is what is signal? Here we will see the interaction between signal and system. A signal can be continuous time signal or a discrete time signal. Okay, how to obtain discrete time signal from continuous time signal, that also we'll see. उसको भी हम लोग देखेंगे कैसे हम लोग डिस्क्रीट टाइम सिग्नल को कॉन्टिन्यूस टाइम सिग्नल से ऑब्टेन करते हैं। ठीक है, वहां पर कुछ ऑपरेशन होता है, उस ऑपरेशन को हम लोग क्या बोलते हैं? सैम्पलिंग, राइट? तो ऑल दोज थिंग्स वी विल सी। ठीक है, तो ये बेसिक चीजें मैंने आपको बता दिया कि बेसिकली क्या है। और हम लोगों को जो बुक रेफर करना है, उस बुक का नाम है ओपेनहाइम। ओपेनहाइम, इस बुक को आपको रेफर करना है, ओपेनहाइम, और इनका लेक्चर भी है एमआईटी, दैट आल्सो यू गाइस कैन रेफर। क्योंकि जो भी गेट में सिलेबस दिया हुआ है, ओपेनहाइम और एमआईटी में इनका लेक्चर दिया हुआ है, एमआईटी ओसीडब्ल्यू में। यू गाइस कैन रेफर दैट लेक्चर एज वेल along with my next. What is signal? Very first question is, what is, can somebody tell me what is signal? The signal is basically, let me see your comment as well. Yeah, if you understand what is signal, you guys can also write your definition in the signal. What is signal? So keep in mind, any physical quantity we will, any physical quantity can be regarded as signal. Okay, can be regarded as signal that conveys some information. Okay, if any physical quantity is there, if it conveys some information, you can say, right? Okay, so the first property is what? Any physical quantity should have two kind uh, two or three properties. So if physical, any physical quantity, if it conveys, is you can conveys information, it conveys some information, or if it exhibits some variation, okay, if it shows some variation, okay, any physical quantity will be there. If it does not have any variation, then it cannot be regarded as a signal. If I say that the battery is a signal, the battery is what? Constant. Okay, the battery is constant basically. Whatever battery you connect, okay, the network, okay, that battery is constant. Okay, if it is not having any kind of variation. Variation means kya? Change with respect to some parameter. Okay, that parameter will be time. तो सिग्नल क्या होता है? सिग्नल बेसिकली एनी फिजिकल क्वांटिटी इफ इट कन्वेज सम इंफॉर्मेशन। सपोज वो सिग्नल ऐसा है, मतलब वो फिजिकल क्वांटिटी ऐसी है जो कोई भी इंफॉर्मेशन कन्वे नहीं करता है, यू आर नॉट अंडरस्टैंडिंग एनीथिंग, एंड दैट इज नॉट अ सिग्नल, राइट? ठीक है, इफ इट कन्वेज सम इंफॉर्मेशन, ओके, अबाउट सम फेनोमेना, यू अबाउट, ओके, दिस इज फर्स्ट डेफिनेशन, कीप इन माइंड, and it typically exhibits, you can say, variation. Variation is any physical quantity, okay, if it is varying with respect to time or with respect to any other parameter like x, y, z. You will see also in electromagnetic, right? Electromagnetic wave. Electromagnetic wave will be the function of space as well as time. Okay. I will give you some kind of a signal like audio signal, voice signal, video signal. There are different kind of signals. They are okay. So if they vary with the time, right? If they exhibit some kind of variation, uh, space and time, that can be regarded as signal. I hope this makes sense. So this is the real time definition. Okay, this is basic definition you have to understand. Okay, so what kind of signals are there? Okay, which shows variation in space? You can say image. Okay, so image will be having, image always has many pixels. You can this kind of this is image. These are the pixels. These are the pixels. There are many pixels in the image. So I am just denoting IX. Image is basically two-dimensional signal. Okay, because the intensity, intensity will vary with respect to space parameter x and y. Okay, the image is one of the good example of signal, right? Because it exhibits variation. Okay, and with respect to time, if you want to tell, wave, electromagnetic waves. Okay, electromagnetic waves is also one kind of signal. Whatever, suppose you are talking with your friend, and whatever you are speaking, okay, that goes to space first, right? Then it gets back to your receiver. Understand, your friend is able to understand what you want to convey, right? So after all, you are conveying some information, okay, in the form of signal, right? Your voice is a kind of signal. तो आप जो भी करते हो अपने लाइफ में, सारा का सारा सिग्नल ही है. You send some signal, you get some response in the form of words, text, speech, video. तो अगर उसमें कोई वेरिएशन नहीं है, देयर इज नो वेरिएशन, constant, if it is a constant, right, can't say that is a signal. Keep in mind that. And if I talk about one of the important, this is first example. Second example, third is video. Video is what kind of signal? It is a moving picture. You can say moving picture. Moving picture it is a function of space as well as time. Okay, video is basically three dimensional. Okay, signal can be one dimensional, signal can be two dimensional, multi-dimensional, right? This is one of the first, you can say, classification. Okay, so signal can be what? Here I'm writing. Signal can be one dimensional, dimensional, dimensional. Okay, one dimensional signal you can say is your voice. Your voice is one dimensional. The amplitude of the voice is varying with respect to time. Two dimensional signal you can say is the image. You go to you go to the hospital, right? And you just get checked your heart, right? What kind of signal you will get from the heart? That signal is known as ECG. People call it ECG, right? ECG, electrocardiogram. Okay, electrocardiograph we get. Okay, ECG waveform we get, right? So ECG waveform look like this, like this. So there is some, letters written PQR. These letters we can't understand. Only doctor understand them, right? So this is also one kind of signal, ECG waveform. Okay, which you see always on the CRO, okay, when as your heart fluctuates, right? This kind of signal you might have. Okay, so this is very very important. So how does we capture the variation? How does we capture? How do we model? How do we model the variation? Mathematics. What we will do here is any signal, if it is one dimensional, always model with the x of t or function of time. Okay, or you can say function of time, x of t, y of t, right? Okay, x of t or a y of t. So this is known as time varying, time varying. Okay, so your xt is a dependent And here time is in, okay, time is not dependent on us, we are dependent on time, right? Okay, the function. So you can say mathematically signal is a function of time, okay, which conveys some information, okay. If it does not convey any information, it cannot be regarded as a signal. That you have to understand always, okay. If any physical quantity, it exhibits some variation with respect to space or time, if it does not convey any kind of information, क्या है इसको आप सिग्नल नहीं बोलोगे, ठीक है। याद रखना ये पॉइंट, ये चीज लोगों को समझ में नहीं आती है, ठीक है। तो हम इसको क्या बोलते हैं मैथमेटिकली, हम इसको बोलते हैं फंक्शन ऑफ टाइम। मैथमेटिकली आप बोल सकते हो फंक्शन ऑफ टाइम। एंड this is the last, okay, I'm telling you the definitions, right? I will not repeat again and again. Just for the sake of introduction, I'm telling you all those things because today is our first class of signal and system, right? Okay. I hope this makes sense. Now we will talk about signal classification. What we will discuss here? Signal classification. See, we'll discuss here the classification of signal. Already I have classified signal in one way, in terms of dimension. So signal is a function of time only, that is one dimension. Signal can be the function of two variable, can be function of multivariable. Okay, so signal is a mathematical function, okay, which is a function of what? Function of independent variable. So signal is a dependent variable which is a function of independent variable. Can be independent variable, can be one, can be two, it can be three, and okay, so accordingly you can decide the dimension of the signal. Okay, so whatever you speak is a signal, okay, it is a kind of signal, your voice. And if this voice gets recorded in the form of audio, okay, that is also kind of signal whose frequency will be more. You guys can increase, the frequency of audio signal, right? But you are limited to generate frequency of your voice, right? That will be limited. But if your voice is recorded to the system, understand, the recorder you can say, right? So you can adjust the frequency, you can keep your volume at a high stereo, frequency will increase. That's why 20 to 20 kilohertz, okay, we are able to generate the frequency of audio signal. So okay, so I'm not talking about any frequency component here. Those things discuss in communications. Here just we have to understand what is signal, what are the kind of signal, how we can classify signal. The very first kind of classification there is continuous time. Continuous. What is the meaning of continuous? I think everybody knows from the mathematics what is the meaning of continuous, right? You put your pen on a paper and move your pen, right? Without lifting the pen or plotting that graph, that is the continuous, call it. Continuous time signal, okay? It will be continuous with respect to time, okay? We can also give you some kind of very good example here, right? Suppose I take xt equal to uh, sine 2 pi t. This is one of the good example of continuous time signal, right? This is one of the good example of continuous time signal, okay? So you can also plot it, time, this is continuous time, this is continuous, has continuous variation, has continuous variation, right? If you see, this is, there are many events, you can say, with respect to, there are many events happening. Your sinusoidal, your sine wave is, sometimes it is going high, then it is coming low, it is again going high, okay. So it is continuous. If you take some interval here, okay, you take some interval, you just take some interval, take this, you can say this is t1 and this, you take these two interval or these two events, you can say. So this this signal is defined for all time events. You can this interval, okay, for all time events in an interval. Okay. So how we say that this is a continuous time signal? You take two interval only, T1 and T2, and in between you see here, you know, it is continuous. It is defined. There are many, you can say infinite values are there, right? I hope this makes sense. So this is the interval T1 and this big bracket we are using, right? So T1 is also included here, right? We're not using open bracket. So we have to check continuity in the close interval, right? Okay. So what is the meaning of discrete time signal then? If it is a continuous time signal, xt equal to cos sine 2 pi t, you can give n number of examples. Okay. Okay. Let's move ahead and talk about discrete time signal. Discrete time. We will also talk about the how we convert continuous time signal to discrete time signal. At this moment, I'm not gonna talk. Just I'm defining. Okay. I'm just classifying the signal. Okay. First kind of signal is continuous time signal. I hope this makes. Second kind of signal, discrete time signal. Okay. Discrete. It will not be continuous now. Okay. So discrete time signal. So we denote discrete time signal as x of n. X of n, and where n will be the integer. Integer. In case of discrete time signal, the time t will not be visible. Okay, but n is considered as integer value. Keep in mind that t will not be there. Small t, right? It will be the function of x of n. That you have to understand. So it is defined. Okay, what is discrete time signal? If somebody will ask, what is discrete time signal? What's your definition? The definition should be it is defined is defined at a discrete set of time instant. At a discrete set of time instant. If someone is going to ask you what is the meaning of discrete time signal, what's your definition? Sir, it is defined at a discrete time instant. Okay, time instant will not be continuous. Right? Will be discrete time instant. But we'll see how we convert discrete time signal. How we convert continuous time signal to discrete time signal. So what we are going to do here is suppose this is a continuous time signal, TTS you can. So what you have to do here is you have to pass this continuous time signal to sampler. Okay? And sampler, what is the job of sampler? The job of sampler is to do sampling. Job of sampler is job of sampler is what? Sample or you can sampling. What is sampling basically? Sampling is nothing but discretization of time axis. What is sampling? Discretization. Discretization of time axis. You just discretize the time axis, okay? You don't have to discretize the amplitude axis, okay? Signal will be having two axes. One will be amplitude axis, one will be the time axis. You have to discretize, you have to chop You have to divide the continuous time interval into discrete time instant. So we can take here, we can take, suppose this is a continuous time signal. What we are going to do here is we are going to decide, divide. We are going to chop this off like one. At T1, this is the value here. At T2, now we don't care about what is there in between, between T1 and T2, right? At T2 instant, this is the value. At T3 instant, this is a. So we are picking up some value from the continuous. Okay. So this is how we sample. Okay, sample the continuous time signal. So this is just the definition. How mathematically it is done, that's what I am going to show very soon. If you give TTS to the sampler, what kind of signal it will give you? It will give you DTS, right? Discrete time sequence or signal, we call it. Okay. So what we are going to do here is, what we are going to do, we are giving XT the sampler. Sampler will be like this. Suppose this is an TS. Sampler will be what? It is TS is what here? TS will be known as sampling interval. Sampling TS will be sampling interval. So you just you replace this T by an TS, and we always consider TS equal to 1 second. Normalize it. Okay. If it is not given, so you can always put TS equal to 1 second, right? If it is given, that value you have to put here. Okay. So this can be written now as x of n. X of n. So we call sometimes this as discrete time signal or sequence. Sequence of number also you can say. Sequence of number, because now your signal has been chopped off. Okay. Your signal has been sampled. Time has been discretized. ठीक है. तो आप कैसे इसको शो करोगे? There will be this kind of an impulse, you can one value at this minus, right? This kind of sample value will be there. These are the samples. First sample at -2, one sample at -1, right? Some sample here at you can 0. This sample is at 1, right? Like this. Okay. This axis will be represented with the help of small n. 2. This can be also written like this. This is a graphical representation of discrete time sequence. Why we are calling it sequence? Sequence means any number you would take 1, 2, 1, comma 2, comma 3. Right? So you can write this as x of -2, x of -1. What is this value of a sample at -2? X of -1, of 0, 1, of say 2, right? This is how we represent x of n. Okay. Here sometimes we put some values. Also we'll say that this is n equal to -2, and then n equal to -1, and so on, with the help of an arrow to indicate at what instant what is the value of that sample, right? So this is how we show the discrete time sequence from the continuous time sequence. How we get discrete time signal? How we get discrete time sequence from the continuous time signal? We always pass it through sampler. Okay. And what kind of operation we perform? Sampler perform sampling or operation. What is sampling? Sampling is what? Sampling is nothing but discretizing the time. You will always, and mathematically how we will do in future you will see. Okay. Once we will discuss some kind of signal like impulse signal, right? So we will multiply continuous time signal with the impulse, train of impulse. It will give you a discrete time signal. So those things we will discuss as we go ahead. This is just a brief idea I'm telling. Sometimes discrete times or discrete time signal we also know, say like this is a sequence or series, okay, of numbers, or you can say time series also, or you can say time series are the time series or sequence or series. This is basically time. I hope this makes sense. Okay, so can somebody tell me what are the example of discrete time examples of discrete time real life? Isika, can you tell me what is the what are the example of discrete time signals? See, there are different kind of there are different examples. You can say, your modern 3G, 4G, 3G, 4G. You can say, or call sometimes GSM, set-top box. uh, All these things are discrete time signal. So if somebody will ask, how can we obtain discrete time signal, or you can say discrete time sequence from continuous time signals, what you will say? We can obtain continuous time signal from, sorry, we can obtain discrete time signal TTS from TTS by performing what? Sampling operation. Sampling operation. The sampling chapter we will see in detail. There are different kind of sampling, okay? But this is the introductory class, so I can't teach everything in one go, right? I hope this makes sense. So I have shown also that suppose this is a continuous time signal, continuous, to sample it, right? How we sample, how we sample it. These these are known as samples. They are the samples. Okay, they are the samples, and we call them as sampling interval. Okay, I hope this makes sense. And sometimes we call it sample, or sometimes we call it discrete. I hope this makes. What will be the sample height and given in the question? Okay. So one way of representing discrete time signal is by representing in terms of sequence or series of numbers. In the exam, they will give you this kind of a discrete time signal. Suppose xn is given like 1, 2. They will give you hn. We will see what is the meaning of hn. 2, 4, or they can give you infinite number of sequence. The finite number of sequence, they can also give like this also, right? 1, 2, 4, 8, and so this is how they might give. So you have to understand this is discrete time sequence or discrete time signal. Okay. And one way of also representing sequence is x of n will be given as 1 by 2 to the power n, and it is defined for n greater than 0, 0 otherwise. So if this kind of a representation is given, so you have to regard this as discrete time sequence only. Because if you put n equal to 0, you can put n equal to 1. So you have to take here n equal to 0, 1, 2, and so on. The discrete set of values. Okay, discrete time instant you have to plug. So this is the analytical representation. x of n is given as 1 by 2 to the power n greater than or equal to 0. Don't get frightened that oh my god it is ये क्या है, ये बिल्डिंग ब्लॉक्स मैं आपको बता रहा हूँ. क्वेश्चन आप सॉल्व करोगे ना, आपको सब समझ जाएगा. अच्छा ये डिस्क्रीट टाइम सीक्वेंस गिवन है, डिस्क्रीट टाइम सिग्नल गिवन. अच्छा ये डोंट वेस्ट योर टाइम एनीवेयर. तो ये रिप्रेजेंटेशंस मैं आपको बता रहा हूँ बस. और अभी तो बहुत सारा पढ़ना है. सिग्नल एंड सिस्टम इज वेरी ह्यूज सब्जेक्ट. So you guys can also convert this into graph in terms of samples, right? So suppose x of n is 1 by 2 to the power n, where n is greater than 0, right? This will be given. So you can put here n equal to 0 means it is 1. The sample height is 1. N equal to 1 means sample height is half. And as n increases, your sample will decrease like. It is kind of an exponential decay, discrete. And so you can also say that alpha to the power n. X of n is what? Alpha to the power n. Okay. So here alpha can be greater than 1 and alpha can be less than 1. If alpha is greater than 1, it will be growing exponential. Growing. It will grow like this. Is alpha less than 1 means because half is there, right? It is decaying. Decaying expo. Discrete time expo. Right? I hope this makes sense, guys. Any doubt till this point? If anybody has any kind of doubt, see, I will also teach you how to graph any kind of signal, right? What are the operations? How to add two signals? How to subtract two signals? How to multiply two signals? Various operations we are going to see. Whatever you have done for function in math, you have shifted your function. So I will shift signal as well on the time axis. You have shifted the function in the y-axis, right? I will also shift. Okay, I will multiply by some scalar constant. So whatever we have done with the function, the same operation we will perform on the signal as well, because now we are modeling signal as a mathematical function. Okay, any physical phenomena we are capturing in terms of mathematical function. Okay, that you have to understand. Okay, let's move ahead and take up I hope this makes. First of all, the classification for quantum is discrete time signal. How to obtain discrete time signal or a sequence? See, when we talk about discrete time, we always say discrete time sequence in a correct sense. But most of the book also will say, okay, this is a discrete time signal. But when we talk about DFT or discrete time Fourier transform, right? So there we always say discrete time sequence. Yeah. Next classification will next classification analog and digital signal. Digital signal, analog and digital signal. And okay, nowadays if somebody is interested for analog, right? So they can go for analog mixed signal design, right? There is a specialization, analog mixed signal design. What is the meaning of that? Analog mixed. See, without analog, nothing is possible. First, the birth of signal will be analog only, right? Then there are systems which can convert analog signal to digital signal, right? That we call it A to D converter, right? So most of the candidate who does research in analog, right? So they always design, analog to digital converter, sigma, converter, sigma to data converter, right? Or data digital to analog converter, right? Because the birth of signal is what? Analog in nature. the birth of signal, from the nature, if you are picking of something, okay, which is conveying some kind of information, if there is a variation with respect to time or space, that is a signal. Okay? Now it's your job how we can convert. See, I want digital, right? I want digital signal. So what we will do, we'll put analog signal A to D converter and we'll get digital. Simple. Yeah, because there are some advantages. Nowadays everything is digital, but as I told you, from the nature, all the signal which exist around you is analog in nature. Nowadays we, most of these, student, teacher, everyone, engineers, doctor, everyone prefers what? Digital. A digital watch, everything is digital. But sometimes people are also preferring analog. So analog will never be this, because you have research will be continuous in analog. Okay. Chalo. So what is analog? What is analog? That is what my question is. What is the meaning of analog? Let us define analog. If somebody will ask you what is analog, your definition. The analog is nothing but continuous time signal. What is that? Analog is nothing but a continuous time signal. Okay. Keep in mind, analog is what? Continuous times. Already we have defined what is the meaning of continuous. You can say continuous time signal xt. Okay, which can take which can take any value, or you can say which can take any value, or which can take values belonging belonging to an interval, right? Belonging to an interval a, and you take any continuous time signal, okay, and you take two interval. So what is analog signal? Analog signal is a continuous time signal. That should be your definition. Okay. If somebody will ask what is analog signals, what you will say? Analog signal is nothing but a continuous time signal which can take any values, or you can say values belonging to an interval a and b, right? You just show it also. Draw the continuous time signal and show them, right? Okay. So if I write mathematically the example of analog signal, you see here I'm showing you the example of analog signals. Sine 2 pi ft, the analog signal, okay, that belongs to, can take 1 and mean minus 1 and 1. Okay, it mean minus and 1. Okay, mean minus 1 and 1, or you can say that e raised to power t belongs to 0 and these are the analog signals. These are the analog signals. Sine 2 pi ft is a continuous time signal, okay, which can take any value between these two minus 1. I hope this makes sense. E of t can take any value in this interval, 0 and infinity. I hope this makes sense. Okay. Perfect. So in the exam, in the question, they will mention specifically, if they have mentioned sine 2 pi ft belongs to minus 1 and 1. So you have to understand this is an analog signal. Okay. Perfect. If I show you graphically e raised to power t, what is e raised to power t? E raised to power t is nothing but exponentially growing. Like the growth of, you can say, population is growing in India exponentially like this. It is 1 at 0. Okay. This guy can take, xt can take any value, all the value in the interval 0 and all values, all values in the interval Okay, or 0 in the interval 0 and that's what I'm saying. And what is this? I hope this makes sense. What is analog signal? Analog signal is nothing but continuous time signal. Take the values in the defined interval. What is digital signal? This is very important and nobody knows the definition. Digital signal, in communication system, when we talk about digital communication, in the question nowadays they give mathematical definition of digital signal. And most of the students do not know what they have given in the question. This time I'm telling you something, right? So please keep in mind whenever you go through the question, you will get these information, these building blocks, छोटे छोटे information या small information. कोई नहीं बताएगा आप YouTube में देख लो, कुछ भी कोई डिस्कस मैं आपको बता, ये बहुत ही इंपॉर्टेंट कॉन्सेप्ट, आपको गेट में कैसे क्वेश्चन फोड़ना है डायरेक्टली आपको डिजिटल सिग्नल. So what is digital signal? Digital signal is nothing but a discrete time. चाहिए discrete time. What is digital signal? Discrete time signal. Okay, you can say x of n that can take x of n that can take discrete set of value, discrete set of discrete set of values, or you can say or finite set, finite set of values. So if I write x of n, the exam it will be shown x of n belongs to minus 1 and 1. Means what? X of n can take minus 1. You can say that x of n either takes either take 1, or it can take only two values. Remember, it can take only two values, minus 1 or 1. It is a binary signal, right? Binary kind of situation is there, right? Okay, so xn can take either, xn will be equal to what? Here xn will be equal to minus 1 or two situations. This is the digital signal. Okay, so in case of when we talk about digital modulation schemes, okay, or any question will be given from the digital communication, right? So this is how they will represent okay. So x of n can take only one of two values. Out of these two, xn can take only one value at a time, can't take two values at the same. Okay, so where do we use these kind of signal? Use in the digital communication is one of the very easy topic. Okay, if you understand complete signal and system taught by me, never face any problem in communication, and I will guarantee more than 100% that you will be able to solve all the question from signal and system as well as communication system, right? So guys, this is enough. We'll discuss further classification. I hope you got this. Uh, Learning. Please give your feedback also. How was the started with very basic, did everything like happening around us. Okay. What is happening around us is the analog. Keep in mind. We'll meet in the next session.